Okay, children, I'm going to start the class today. So I'm going to start with the linear motion, motion under gravity, graphs, term test practice, MCQ. So first I will give you some MCQ numbers. You have to do them and I will be marking them one by one. So this is the order. Question number 1, question number 3, question number 4, 5, 13, 14, then question number 16, 17, 18, 19, 21, 22, 23, 28, 30, 32, 33, 35. Let's finish up to this point, then we will continue the other MCQs. So let's start. You can start from question number 1. Answers are provided at the last page. So you can start from question number 1 and continue. If you need something to inform me, you can keep a WhatsApp message. Okay. If you need to inform something, you can keep a WhatsApp message. So let's continue. First one, an object with a constant speed. Question number 1. An object with a constant speed. An object with a constant speed. An object with a constant speed, A, is not accelerated, might be accelerated, it always accelerated, also has a constant velocity. So what is the best answer? An object with a constant speed. Here, pay your attention. It's about the object with a constant speed. It's not about the object with a constant velocity. It's a object with a constant speed. Okay. If the object is having a constant velocity, then there's no any acceleration. If the object is having a constant velocity, then acceleration is not there. But here, it's a constant speed. Then what will happen? What is the difference between the velocity and the speed? Velocity is a vector. It has a magnitude and a direction both. But speed is a scalar, so it doesn't have a exact direction. The direction can change. So what happens? If the object is having a constant speed, yeah, its magnitude will not change. The magnitude of the speed will not change. But what will happen? Sometimes direction might change, because in a constant velocity, as a velocity is a vector, magnitude of the velocity and the direction, both of them are constant when the velocity is constant. But when you come to the speed, it's a scalar, it doesn't have a direction. So what happens? When a constant speed is there, yeah, magnitude will remain same, but direction might change. The direction might change. The change of the direction of the speed in velocity wise, what will happen? It will change the direction of the velocity. It will change the direction of the velocity. So even the constant speed maintains a constant speed value, but its direction can change. Changing this direction can change the velocity. So there might be an acceleration. Acceleration is the difference or the change of the velocity for a certain time, for unit time. So there might be a change of velocity. due to the change of direction when the speed is constant. Why? Speed is constant means this value is constant but not the direction. So the correct answer is might be accelerated. Correct answer is question for the question number 1. Correct answer is part B. Correct answer is part B. The second one, B, might be accelerated. It might be accelerated. Okay, let's continue. I'll explain it again. Now, if a velocity is constant, that means its magnitude and direction both are constant. Velocity means a scale vector, so it has a magnitude and a direction both. If the velocity is constant, direction and the magnitude both are constant. So no any harm of the direction, no need to consider about the direction, it will remain same. As the magnitude is also same, velocity won't change and acceleration is 0. It is when the velocity is constant. But what happens when the speed is constant? Speed is a scalar, it only has the magnitude. So what happens? Magnitude will remain same, but in case of a speed, the object's direction can change. Change in the direction will cause a velocity change, and velocity change will cause a acceleration. So while the constant speed is there might be an acceleration. So the correct answer is B. Okay. Then the third one. Okay, likewise, you can continue with these numbers. You can continue with these numbers. Question number 3. Two cars A and B travel along the same road in the same direction from the same starting place. Better to do a small diagram. Two cars, first one A, the other one B. Two cars A and B travel along the same road in the same direction from a same starting place. Car A maintains a speed of 50 kilometers per hour. A maintains a speed VA 50 kilometers per hour. B is having a speed VB 60 kilometers per hour. But B starts 1 hour later. How many hours will it take for B to overtake A? Yes, definitely B will overtake A. Why? B is having a higher velocity, so with time it will overtake A. I'll say B will overtake A at a time value capital T. So I am starting to measure the time when the vehicle A starts its motion. So for A, if the time is T, then this happens. For B, it's T minus 1. Capital T hours for A when B passes it. And to pass A, for B, it will take T minus 1 hours. Fine. B started 1 hour later. So time spent with beat motion is less than an hour with respect to A. Okay. So for A, the time taken is T. So for B, time taken will be T minus 1 as it starts 1 hour later. Okay. Both of them has started from the same point. So when one overtakes other, both of them has passed the same displacement x. Both cars has the same displacement x when one overtakes other. Why? They started from the same point. So to overtake one, both of them have to complete the same displacement. Okay. But in this case, this is the specialty. Here they don't mention acceleration. But in real case, there should be acceleration. A vehicle can't start from a velocity 50 kilometers per hour. It, definitely, it will start from rest. Little by little, it will accelerate. In the middle of the journey, if it like, it can maintain the constant velocity. So this is the real situation. But in here, they haven't mentioned that. They say it moves with a constant velocity of 50 kilometers per hour. So you have to take it. Be prepared for this kind of questions in your exam also. In our idea, we know definitely a vehicle will start from rest. Initially, it has to accelerate. Then if it like, it can maintain a constant velocity from a middle point. It's the actual scenario. But in some questions, without considering this initial acceleration or starting from rest scenario, what they'll say? They will say that the vehicle maintaining a velocity of 50 kilometers per hour. So we have to take that in that manner and solve the question. But we know it's not realistic. But this is the way that they have given the question. So we have to follow that. These kind of questions are there in your exam. Okay. So I'm not considering any acceleration or equations of motion related to acceleration. Why this no acceleration is not there, only the constant velocity. So I'll go in that manner. So from beginning, this will continue with the velocity 50 kilometers per hour, and it will get a displacement x within a time period capital T. B starts from 1 hour later, and to overtake A, it has the higher velocity, so it definitely will overtake. To overtake A, it will take 1 hour less with respect to capital A because it's starting from a hour later time. Okay, so that's the time case. And to overtake one, both of them has to be in the same displacement as they start from the same point. So for A, I'm writing for A, S equals ut. For A, S equals ut. A has achieved a displacement x with a velocity 50. Time taken is capital T. Now B is passing A, so B has the same displacement. For B, S equals ut. B has the same displacement x. The velocity is 60 and time taken t minus 1. As x is the same value, 50t is equal to 60 t minus 1. 5t is equal to 60 minus 6. So here plus 6 and 60 minus 5t. Okay. So 6 is equal to t. If you can remember, we used hours as our scale. So this is hours. T is equal to 6 hours. After A starts its journey, it will take 6 hours for B to overtake A. That's the question they asked. How many hours will it take for B to overtake A? For B to overtake A, it will take 6 minus 1, 5 hours. So the answer is the D one. It will take 5 hours. Okay. In question 3, distance traveled by cars in km when they meet each other. So as the next question, as the question number 4, they ask this x value. As the question number 4, they ask this x value. X is equal to 50t. 50 into t6, 300 kilometers. 300, answer is C. Answer is C. Okay. Now, this is the most important thing I have to mention. In our normal case in our class, most probably 99% of the sums are realistic ones. That means they start from rest over certain velocity, then accelerates, and if they like, in the middle of the journey, they can keep the constant velocity. So that's the case. But there are some questions in your syllabus. In these questions, they have neglected this acceleration part. They just say that the vehicle moves with the constant velocity. So you have to admire it. You have to solve the question as the way they ask. So this is how you have to solve it. So be prepared for these kind of questions also. Okay. The fifth question is also something like that. In fifth question also, they haven't mentioned any acceleration at the beginning. So it's just the constant velocity. It's not realistic, but that's the type of the question here. Okay. So you have to do the fifth one also. Then it will become normal with the 13th. Okay, let's continue. Okay, I'm going to the fifth one. A car covers the first half of a certain distance. There's a vehicle moving in a certain motion. So no acceleration, so nothing mentioned like that, just the speeds. A car covers the first half of certain distance. Okay. So as they say the first half, I will say it's x. Then the next half, the other half, it's also x. Why? Half means the half. So it will divide the complete journey into two equal parts. Half means it will divide the journey into two equal parts. So the first distance is x and the second distance is also x. And a car covers the first half of a certain distance with the speed v1. No accelerations or anything. Just the constant speed v1 in the first half. And this is not realistic, but this is the way that they have given us. And the second half with the speed v2. Now this is what you will think. Now for the first half, it maintained a velocity speed v1, and how it can change its velocity to v2 without a time passing for acceleration or retardation. After a certain velocity, if it need to continue with another constant new velocity value, it needs a certain intermediate time from one to change its motion from one velocity to other. Okay, with the acceleration or retardation. That's the realistic thing. But here it's not the type of the question. This is what just they say. For the first half, for the first distance x, it has a speed v1, and for the other distance, the next half, for the other part, it has a speed v2. So you have to take it and let's solve. The average speed during the whole journey is. So average speed means average speed. Average speed is the total distance over total time. Average speed total distance over total time. So I'll say for the first half, it will take T1. The time taken is T1. For the second half, time taken is T2. For the first half, time taken is T1. For the second half, time taken is T2. Okay. And I know the average speed means the total distance over total time. So already I know the total distance. For the first half, it's x, the distance. For the second half, again x. So the total distance is 2x. And for the first half, the time is T1. So the total time will be T1 plus T2. So my answer is average speed 2x over T1 plus T2. But T1 and T2 are my symbols. I have to convert them to some other manner. Okay. For the first half, I'm applying S equals ut. The distance traveled x, speed v1, time t1. So x over v1 will be the replacement for t1. So here 2x over t1 is replaced from x over v1 plus for the second half. For the second half, I'm applying S equals ut. The displacement is x. The velocity is, surprisingly, it's v2 now. I don't know how it was achieved through a real engine, but they say okay. So the second part, the distance x, speed v2, time taken t2. So for replacement for t2 is x over v2. Okay, here's the thing, x over v2. So the average speed 2x over x over v1 plus x over v2. I'll take x outside. 1 over v1 plus 1 over v2. So x will cancel out. So here you have 2 and here you have to solve this. 1 over v1 plus 1 over v2. So I will take v1, v2 plus v1 here. v1 and v2 can take to the top. So the average speed is equal to 2. I'll take in this to the top. 2 v1 v2 over v1 plus v2. So my answer is the dth one. Okay, answer is the dth one. I'm not considering whether this is realistic or not. I'm just solving what they have given us. There are some questions like this, so you have to admit this. Okay, that's why I gave you. So no accelerations. So what's going on here? First half, time taken t1, speed v1. Second half, time taken t2, as they say. I don't know. It's surprisingly you can't do this with a real engine, but according to them, suddenly it changed the velocity to a new value v2, and it continued that v2 velocity for time t2, passing a distance x again. Okay, average speed, total distance over total time. Okay, the total distance is 2x now, total time t1 plus t2. In each case, I subjected t1 after applying s equals ut for each part separately. Then I got t1 and t2 in terms of x and v1, and I'm substituting them here. Then what happens? X will cancel out. Then I have to simplify. Then I got the answer. Okay, let's move to 13th one. The 13th one. Question number 13. A stone dropped from a top of a tower. A stone dropped from a top of a tower. A stone dropped from a top of a tower travels 25 meter in last second of its journey. So it's dropped from a tower top. Drop means its initial velocity is 0. Drops mean its initial velocity is 0. Travels 25 meters in the last second of its journey. It will travel 25 meters. It will travel 25 meters in the last 1 second time. Last 1 second time. The height of the tower, you have to find that. Okay. Now, the total height of the tower is h. The total height of the tower is h. Total height of the tower is h. And it starts its rest, its drop. And within the final second, it will continue for 25 meters. We have solved a question like this earlier. So what's happening here? I'm applying S equals ut downwards, S equals ut plus half at square. I'm applying S equals ut plus half at square downwards for the final second. For the final second. Okay. So it's coming from the top. When the final second is started, its initial velocity is u. This is not the initial velocity for the complete drop. This is not the initial velocity for the complete journey. This is the u, let's say u dash then. U dash is the initial velocity for the final second. U dash is the initial velocity for the final second. U dash is the initial velocity for the final second. So within the final second, it will travel 25 meters. Within the final second, it will travel 25 meters. Initial velocity. When the final second starts, its initial velocity is u dash. From there, there's only 1 second left to complete the journey. Time taken from there is 1 plus half. When object is starting from a higher point and when it's coming down, acceleration of gravity is plus 10 according to the sign convention. And from this, for this final 25 meters, it took 1 second. So the distance traveled 25. U dash is the initial velocity when it starts its final second. From there, another 1 second is left, plus half, plus 10, 1 square. So 25 is equal to u dash plus 5. U dash is equal to 20. We have solved a question like this earlier. Okay. So u dash is the value 20. 20 meters per second is the velocity when it starts the final second. Okay. Now I'm applying v square is equal to u square plus 2as. Now I'm applying v square equal to u square plus 2as. Now I'm applying v square is equal to u square plus 2as. from the beginning until the final second. Okay, I'm applying v square is equal to u square plus 2as from the beginning until the final second. When it starts the final second, the velocity is u dash here. When the journey starts, the initial velocity is 0 plus 2 g h. So this is the h. This is h. I'm applying v square is equal to u square plus 2as. I'm applying v square is equal to u square plus 2as from the initial point. So the initial velocity is 0 when it's dropped. 2 plus 10. The distance it come downwards. The displacement it gains downward is h, and the velocity it will gain is u dash. So this is from the beginning until the final second. So here in this h, it doesn't contain any detail about this final 25 meters. This h is the distance it came down until the final second. Okay, so this part is the h. When it starts the final second, it had a velocity 20 meters per second. So it will be the final velocity with respect to the journey earlier to the final second. The starting velocity for the final second will be the final velocity for the journey before the final second. So the final velocity for the journey before the final second will be 20. Here 20 is square. Initially it was dropped, so the initial velocity at the beginning is 0 to a s h 20h. So 20 square is equal to 20h, so h is equal to 20. So before the final second, it has moved for 20 meters, and in the final second, it has moved another 25 meters. So the total height, let's say it's capital H, total height of the cliff, let's say capital H is equal to 20 plus 25. H is equal to 20 plus 25, 45 meters. So the answer will be the first one, simple A. Okay, now the 14th one. 14th one. Question number 14. The balloon is going vertically upwards with a velocity of 12 meters per second. There's a balloon, and this balloon is moving vertically upwards with a velocity 12 meters per second. So here's something you have to understand. When a stone is thrown upward, when a stone is thrown upward, little by little, its velocity will decrease. Its velocity will decrease due to the acceleration of gravity, due to the attraction from the earth. When a stone is thrown vertically upward, with time, its velocity will decrease. But in here, this balloon is, as they say, it's moving with the velocity 12 meters per second. So it hints that this balloon is having a constant velocity upward. So how it happens? Definitely, this balloon is not in a motion under gravity. So this is not a normal balloon. This might be a, in some sports and some adventure trips, there are some balloons like this. In your heat lesson, we can learn about these balloons. There's a separate mechanism for this balloon to keep this velocity constant. If it is just a stone which is thrown upward, it can't maintain the constant velocity upward. Definitely, its velocity will reduce due to the attraction from the earth. But if it has an engine or a different mechanism, it can maintain a constant velocity upward. So it's a balloon like that. So it's maintaining a velocity 12 meters per second as a constant value upward. So definitely it's not the motion under gravity, that balloon. It's having a different mechanism. You will be taught it in heat lesson, how a balloon can continue with this constant velocity without decreasing while moving upwards. Okay, so this is not the question. So the balloon is moving in that method. Meantime, when it is 65 meter above the ground level, when the balloon is 65 meter above the ground level, when the balloon is 65 meters above the ground level, a stone is gently released from it. There's a person inside, and what has happened? This person gently, without a velocity, release a stone. As they say, what's happening here? Gently release a stone. So you have to understand this question. A balloon is moving vertically upward. If this balloon is like if we consider it as a stone, when a stone is thrown upward, it can't maintain a constant velocity in an upward direction due to the gravitational pull. It will decrease the velocity. So in this case, it hints that this is a different balloon keeping a velocity 12 meters per second upward as a constant value. In heat lesson, these type of balloons will be explained, how this velocity is kept constant while the acceleration of gravity is there. The upthrust will do the work, upthrust force will do the work. Okay, let's say we have to admire this 12 meters per second constant velocity upward. Now it's 65 meters from ground. It's 65 meters from ground. And at this 65 meter height, a gently a stone is released. Then what will happen? After this 65 meter height, when gently a stone is released, yes, the stone is released gently, but all the objects inside the balloon has the same velocity as the balloon. So even though this person releasing this stone gently without the velocity, what will happen? It's also having a velocity of 12 meters per second. It is also having a velocity of 12 meters per second. Why? All the objects were in the motion with the balloon, so all of them had the velocity of 12 meters per second. I'll tell you an example. When you are traveling in highway, you start from Maharagama, Kottava, and you move to Galle. And what happened? Your vehicle also moved to Galle, and inside the vehicle you are there, and you are also moving to Galle. Both of them can exit from the Galle itself at the same time. What is the meaning of that? If you are inside the vehicle, you are also having the same velocity as the vehicle. You are also moving in the same way as the vehicle moves. So this stone is inside the balloon before it was released. So at the releasing point, the stone also had a velocity of 12 meters per second, which the balloon had in the upward direction. So after releasing from the balloon, this stone will come to the normal environment. How it comes? It comes as a object starting from height 65 meter with the upward velocity 12 meters per second. With the upward velocity 12 meters per second. So this is the case. And until it reaches the zero velocity, this stone will go up and it has to come down again. So this is the journey of the stone after it is released. As the balloon is having a constant 12 meters per second velocity, all the objects inside the balloon also had the same velocity upward. So at the releasing point, even though it's released gently, still the stone is also having a 12 meters per second velocity upward, and until it becomes zero, it will move upward and then it will turn back and come to the ground. When it's come to the ground, it has to come another 65 meters with respect to its releasing point, as it was released at a 65-meter height. Okay, time taken for the stone to reach the ground is capital T. Applying S equals ut plus half at square, applying S equals ut plus half at square to the stone, I'm going to measure the displacement from this place, starting point. I'm going to start to measure the displacement from this place from a height 65 meter above the ground level. So when it comes back, it has to pass the same level and come for another 65-meter height downwards. So when I'm applying equations upward, its final displacement is minus 61. As after it starts its journey with the velocity of 12 meters per second upward, it will move up, then come back, pass the same level and go downwards for another 65 meters. So when applying S equals ut plus half at square upwards, its final displacement is minus 65. Initial velocity is plus 12 to the upward direction, time taken t, plus half as its object that starts to move upwards. Acceleration of gravity is minus 10 t square. Okay, so here minus 65 is equal to 12t minus 5t square. Taking this to this side, 5t square minus 12t minus 65 is equal to 0. Okay, now I have to solve the quadratic equation. 65 times 5. 65 times 5. Then what can I do? Dividing 65 by 5, I'll get 13, 25 into 30. So that's the case. 65 into 5, it's not matching here. 65 into 5, it's not matching. Divide 65 by 5, I got 13, multiplied 5 by 5, 25. Then I'll get the correct difference. I need to have minus 12, so plus 25 minus 30. 5t square plus 25t minus 13t minus 65 is equal to 0. 5t square plus 25t minus 13t minus 65 is equal to 0. 5t, I'm taking outside, t plus 5, taking minus 13 outside, t plus 5 is equal to 0. T plus 5, 5t minus 13 equal to 0. So t is equal to minus 5o. 5t is minus 13, 0 means 5t is 13. T is 13 over 5. So this is the correct answer. Time is a positive value. T is 13 over 5. Okay. So what's the answer you get? 13 over 5. For the 14th question, answer is C. $2.6. I got 2.6. There's the answer is not there. So let's check. Balloon is going vertically upwards with the velocity 12 meters per second. When it is 65 meters above the ground, a stone is gently released from it. So at a 25-meter height, the stone comes to the normal environment with the velocity that it get through the balloon, upward velocity 12 meters per second. It will move until its velocity is 0 due to the acceleration of gravity downward, and it will turn back and come back again. So when it hits the ground, its displacement with respect to the initial point is minus 65, 12t plus half minus 10t square. 65 12t minus 5t square, 5t square minus 12t minus 65 0, 5t square. Here I have done the mistake. It should be minus 25 plus 30. It should be minus 25 plus 30. Minus 25 plus 30. 5t square minus 25t okay. Taking 5t out, t minus 5. Taking plus 13 out, t minus 5. 0. T minus 5. 5t plus 13 is 0. T is equal to 5 from here. 5t plus 13 0. T will be minus 13 over 5, and it's the wrong answer, as t is the positive value. So t is equal to 5 seconds. Question. The answer is C. Answer is C. Okay. Okay. Let's move to the 16th one. Question number 16. Two bodies of mass m and m2 are dropped from a height h1 and h2. Two bodies of mass m1 and m2. First one having a mass m1. Second one is having a mass m2. Are dropped from a height h1 and h2. They are dropped from different heights. So this is the ground level. First one dropped from a height h1. They haven't mentioned what is the larger one. So I'll take h1 is larger and this is h2. h2 respectively. The ratio of times taken for them to reach the ground is, you know, acceleration of gravity is not affected by the mass. So even the masses are different, it will not change any kind of a acceleration caused by the earth. So that's the first thing you have to understand. So even the masses are different, m1 and m2, it will not change its later motion. Okay, so I'm not considering the effect of masses m1 and m2. The masses are not affected. Acceleration of gravity is not affected by the mass. So both of them having the same acceleration of gravity. Okay. For this will come to the ground after time t1. This will come to the ground after time t2. For m1, no need to consider the mass. It will not affect the motion under gravity. Just applying S equals ut plus half at square for the mass m1. It has to reach a distance height h1 towards ground. Initial velocity is 0, half. It's also facing the acceleration of gravity g, t1 square. Applying S equals ut plus half at square to mass m2. Due to the mass, nothing will change. It has to come a displacement h2 towards ground. Its initial velocity is also 0, half g t2 square. So h1 is equal to half g t1 square. h2 is equal to half g t2 square. Dividing them, h1 over h2, g will cancel out, t1 square over t2 square. So root h1 over h2 is equal to t1 over t2. So the ratio of the time that takes to reach the ground, t1 over t2 is equal to root h1 over h2. t1 over t2 is equal to root h1 over h2. Answer is the first one. Answer is the first one. Question number 16. Okay, the next question is question number 17. Question number 17. Question number 17. An object covers a distance in direct proportions to the square of time elapsed. Its acceleration is. Now, this is a kind of a tricky question. An object covers a distance in direct proportions to square of its time elapsed. That means simply, if there's an object, when it moves, the displacement it gains is proportional to the time square. The simple meaning of this sentence is that when an object is moving, the displacement that this object is obtaining is proportional to the square of the time taken. So I can remember an equation like this. There's an equation s equals ut plus half at square. There's an equation s equals ut plus half at square. There's an equation s equals ut plus half at square. It's a general equation. If the initial velocity is 0, if the initial velocity is 0, that means the u value is 0, then this equation will become s equals half at square. So s is proportional to t square. S is proportional to t square. If the acceleration is a constant. So this is what you have to understand here. There's a situation in this question, an object covers a distance. Simple meaning, the displacement of the object is proportional to time square. I found an equation that I can go to the answer. It's s equals ut plus half at square. It's a general equation. It's correct for any object in a constant acceleration. But if this certain object is having an initial velocity 0, this equation will become s equals half at square. So that's what they are mentioning. S is proportional to t square. So simply, this is an object which started from rest and moving with a constant velocity. So by looking at all these things, I can conclude this is an object that starts with rest. So u will become 0 and s will become half at square. And the same time, it's an object with a constant acceleration. If acceleration part is constant, then simply s is proportional to t square from here. So this is an object which started from rest and maintaining a constant acceleration. Maintaining a constant acceleration. Okay, so its acceleration is constant d. Its acceleration is constant d. I'll give you an interval after the 19th one. I'll give you an interval after the 19th one. I'll give you an interval after the 19th. Question number 18. A particle starting from rest has a velocity that increases linearly with time v equals kt. Now, this is also a tricky question. It's not a question to simplify and get the answer. You have to think. Now, in this case, they say about a particle starting from rest and velocity that increases linearly with time under v equals kt. So simply what this means, there's an object starting from rest and moves with a certain method, and this method can be explained by v equals kt. Its velocity is equal to k into time t. There's an object starting from rest and it moves in a straight line, and at a certain stage its velocity v is equal to a constant into time t, v equals kt. So I can remember an equation, a general equation, v equals u plus at. I can remember general equation v equals u plus at. If v equals u plus at, it's a general equation, and if initial velocity is 0, this will become v equals at. If initial velocity is 0, this will become v equals at. So it's the same way as they say. They say it's v equals kt and we got v equals at. Both are same. So k is equal to a. That's what they are trying to tell us. So acceleration is a constant. They are in the same pattern. It's a different question. You have to think and get the answer. Generally, there's an equation v equals u plus at. So if v equals u plus at, and if in this case, if the initial velocity is 0, v equals at. V equals at. So this is what we got. And this is what they say. V equals kt. Both are rhyming. Both are in the same way. So that means a and k are same. So the k refers the acceleration. Okay. And what's the question they ask? Then the distance covered by it in first 3 seconds. S equals ut plus half at square is a general equation. And we know due to this rhythm, initial velocity is 0. So this will come to a simplified stage called S equals half at square now. Why? There's a general equation v equals u plus at, and if u is 0, then it seems to be v equals at. Here the object is following an equation v equals kt. Both of them are rhyming. So this is the situation. This is the object with the initial 0 velocity and moving with the constant acceleration, believing v equals u plus at. That means v equals at, no u, 0. So this is the situation. So this, for these kind of objects, there are another 3 equations. One is s equal ut plus half at square. And as the initial velocity is 0, for this thing to be correct, initial velocity should be 0. So I can apply that here also. So s equals half at square is the situation. So after 3 seconds, s equal to half a 3 square. So after 3 seconds, s is equal to half a 9. And by looking at this, v equals at and v equals kt, we conclude that here k represents the acceleration. So we can add it here. So s equal to half k 9. 9 over 2 k. After 3 seconds, its displacement is 9 over 2k. The dth one. Dth one. Okay. I'll be giving you an interval after this question. Question number 19. When two bodies move towards each other, It's a very good question. This is body A. This is body B. When two bodies move towards each other with constant speeds, the distance between them decreases at a rate of 6 meters per second. What is the definition of the velocity? What is the definition of the velocity? Displacement per second. The definition of the velocity is the displacement per unit time. The definition of the velocity is the displacement per unit time. So, this body is moving towards A is moving towards B and B is moving towards A. So, after 1 sec, if A is having a velocity V1, after 1 second, it will come a distance V1 towards B. What is the definition of the velocity? The definition of the velocity is the displacement per unit time. So within a 1 second time, capital A will come a displacement V1 towards B. And B is in this direction. So the velocity means the displacement per unit time. So within a 1 second time, B will come close to A by a displacement V2. So within a 1 second time, A and B get closer to each other by V1 plus V2. Within 1 second time, A and B get closer to each other by V1 plus V2. So, within a 1 second time, A and B get closer to each other by a distance V1 plus V2. Why? The definition of the velocity is the displacement per unit time. So now they are moving towards each other. So first one, A will move a displacement V1 within a unit time, and B to this direction it will move a displacement V2. So with respect to the initial situation, now A has moved the displacement V1 to this side and B has moved the displacement V2 to this side. So they are closer to each other by a distance V1 from this side and V2 from this side. The total displacement total distance that they came closer is equal to V1 plus V2. As they say, the total distance that they came closer to each other within 1 second is 6. So V1 plus V2 is equal to 6. Now the second case. Now when they are moving outside, when they are moving up other ways, what happens? This is A moving in this direction. This is B moving in the opposite direction. So the definition of displacement is the distance per unit time. So A is having a velocity V1. Now in this case, A has moved outwards from a distance V1. A has moved outward from a distance V1 within 1 second time. When they are moving other ways, within a 1 second time, the displacement per 1 second is the velocity. So V2 is the displacement that it gets within a 1 second time. So it has moved a distance V2 to this side within a second. So with respect to their initial positions, now what has happened? The distance between them the distance between them decreases at a rate of 6 meters per second. If they move in the same direction with same speeds, when two bodies move towards each other with constant speeds, the distance between them decreases at a rate of 6 meters per second. If they move in the same direction with same speeds, when two bodies move towards each other with constant speeds, when two bodies move towards each other with constant speeds, the distance between them decreases at the rate of 6 meters per second. Why? The distance between them decreases. Why? Both of them are coming closer. This one comes a distance v1 within 1 second. This one comes a distance v2 within 1 second. So, with respect to the earlier situation, now they are closer to each other from a distance v1 plus v2, and that value is 6 with respect to a second. If they move in the same direction with the same speed, so here we have to correct the answer. If they move in the opposite direction with the same speed, you have to correct it. You have to correct it here. If they move in opposite directions, if they move in opposite directions, what will happen? If they move in opposite directions, what will happen? They will separate themselves more and more. Okay, in that case, this one is moving a distance v2 outward, and this one is moving a displacement v1 outwards to that side. Okay, and distance between them increases at a rate of 4 meters per second. Let's say v2 is larger. Let's say v2 is larger. Let's say v2 is larger. So this is the higher distance that this one is separating from the other one, and here this is the smaller distance v1 with respect to a single second that this one is moving. So within 1 second, the distance they separated themselves will be v2 minus v1. v2 minus v1. Why? To this side, this one is moving a displacement v2 within 1 second. I'm sorry, there's a mistake. I'll explain it again. I'll explain it again. Here, when two bodies move, okay, I'll explain it again. Wait. When two bodies, I'm explaining it again. When two bodies move towards each other with a constant speed, there are two bodies. Wait. They are moving towards each other. There are two bodies, A and B, moving towards each other with constant speeds. The distance between them decreases at a rate of 6. Capital A is coming a distance, let's say XA to this side, and capital B is coming a distance XB to this side. So okay, now capital A is coming towards B, capital B is coming towards A. So capital A comes a distance XA, in the time capital B comes a distance XB towards this side. If this time period is 1 second, if this time period is 1 second, the distance, the displacement per 1 second is the velocity. So it's the VA value here, as velocity is VA. And if the time period is 1 second, the displacement per 1 second is the velocity value. So the distance it came to this direction is equal to the velocity value, VB. So now they are coming closer. So within a 1 second, this will move a distance VA. Velocity is the displacement per 1 second. So within a 1 second, this will move a displacement VA to this side. This will move a displacement VB to this side. So they will come to each other. They will come closer to each other by a distance VA plus VB within a 1 second time. That value is equal to 6. So that's what I wrote earlier also. That part is correct. But I made a mistake in the second part. In the second part, this is what they are saying. Now both of them are moving in the same direction. Now both of them are moving in the same direction. I have done a mistake when drawing the diagram. Now A is moving in this direction with the velocity VA. So within a unit time, it will move a displacement VA. It will move a displacement VA. As its velocity is VA, velocity is the displacement per unit time. So within a unit time, it will move displacement VA. Let's say VA is the larger value. And what happens next? Capital B, it's having the velocity value B, VB. And now both of them are in the same direction. Per unit time, it will move a displacement VB. It will move a displacement VB. It will move displacement VB. Okay. So what will happen here? Now both of them are moving in the same direction. Now both of them are moving in the same direction. And when they are moving in the same direction, within a 1 second time, A will move a distance equal to its velocity. Velocity is the displacement per 1 second. So it's VA. In the same direction, we will move a displacement equal to its velocity value VB. So now what is the gap between them? It's VA minus VB. Here the distance is VA. Here the distance is VB per 1 second. So what is the gap between them now? That's what they have mentioned. It's VA minus VB. So what is the gap between them after this first second? It has moved VA. This has moved VB. So this gap, this is equal to VA minus VB. If they move in the same direction with the same speed, the distance between them increases at a rate of 4 meters per second. So now what is the gap? The distance in between them is equal to 4. So this is the case. It is the second equation that I have to take. So VA plus VB is equal to 6. VA minus VB is equal to 4. When I add them, VA plus VB plus VA minus VB is equal to 10. VB will cancel out. 2VA is equal to 10. So VA is equal to 5. VA is equal to 5. And when VA is equal to 5, you know VA plus VB is equal to 6. Then what has happened? VB is equal to 1. VA 5, VB 1. One velocity is 5 and the other is 1. Answer is A. Answer is A. Okay, so this is the question number 19. Shall I explain it again? Earlier I have done a mistake. when I read the question, I drew it in the other way. First part was correct. For the second part, I have drawn a separate image. So I corrected it. So this is the situation. Here I took the advantage of this definition of velocity. Definition of the velocity says velocity is the distance displacement per unit time. When they are coming to each other, coming closer to each other, within 1 second time, this will come close by a velocity value VA. Why? The velocity is the displacement per 1 second. So let's say it's having a displacement XA towards this side. If it is a 1 second time, the displacement will be equal to the velocity value VA. And this also coming towards the other one from a displacement XB. If this is 1 second time, the displacement within a 1 second is equal to the velocity. So it's coming a distance VB towards this side. So they are getting closer. The rate of the situation, rate means per 1 second. This is coming VA, this is coming VB. So they are getting closer from a distance VA plus VB within a 1 second time. VA plus VB is equal to 6 as they mentioned. When they are coming, it's when they are coming towards each other. When they are moving in the same direction, from here within a 1 second, this will move a displacement VA, this will move a displacement VB. So there will be if let's say VA is larger one, then there will be a small gap here. As they say, that gap, the difference, the separation is equal to 4. So it's the separation is VA minus VB. VA minus VB is equal to 4. Now I have two equations, added them, then VB will cancel out and 2VA is equal to 10, VA is 5. Then the other one is 1. Okay. So this is the 19th question. Now it's 10:14. I'll start again at 10:30. I'll start again at 10:30.